With the demands of emissions and performance in our combustion engines for cars and machinery, more and more manufacturers are using electronic thermostats. So what are they? Why do we use them? How do they work? And are they any better? So when it comes to any liquid-cooled engine, we need to regulate how much coolant is allowed to go to the radiator to be cooled and how much is held in the engine so the engine can warm up properly. Now, typically we would use a wax pellet and spring type thermostat or regulator like this one here. This one is designed to open up at 82 degrees. It has a wax pellet inside the element. When the wax heats up, it expands, and that forces the thermostat open and allows coolant to flow to the radiator. It has a spring that closes it. Once the wax cools down and returns to a solid, it will close and it will stop any coolant going to the radiator to maintain temperature in the engine. These have worked perfectly fine for decades, but now with increasing needs of emissions and performance, we can use an electronic or an electronically assisted thermostat so we can control precisely how much it opens and at what temperature. Now, as I mentioned earlier, there are two types of this modern electronic thermostat. We have a map-controlled thermostat, also known as an electronically assisted thermostat. We normally find these in cars and light vehicles. And we have this electronically actuated thermostat from a heavy vehicle here, which only uses a piston like this one to shuttle backwards and forwards to control the direction of coolant within the thermostat and uses no wax pellet at all. Okay, so starting with the electronic actuated thermostat, we have a body, a housing with two outlets and one inlet. We also have a piston which works backwards and forwards on a thread. We have a motor that drives that thread, and we have a control unit that controls how much voltage goes to the motor in order to open and close the piston. The piston will decide whether the coolant is to go through the radiator through outlet number 2, or it returns back to the water pump with no cooling at all. So if the engine needs cooling, of course the piston will retract and it will open up the port to the top tank of the radiator, so all the water coming out of the engine can go to the top tank of the radiator and be cooled to return to the inlet of the water pump. If the engine needs to warm up, the piston will advance and it will close the outlet to the radiator and open the outlet to the water pump. Therefore, the liquid or coolant will be recycled back into the water pump without going through the radiator in order to warm up the engine faster. And of course, it can be a combination of the two. The piston can half advance or half retract, and it can allow some coolant to go to the top tank of the radiator and some to be bypassed to the water pump, regulating just how warm the engine remains. Now, this is all controlled through the engine ECM, the temperature control module we have here, and a sensor that's usually in the engine block determining what the temperature of the coolant is and advising the ECM to advance or retract the piston based on the cooling needs of that sensor. There is also a manual override. If anything goes wrong, we can advance and retract this piston externally using a small ratchet, and usually we would open the piston all the way up, allow full cooling through the radiator so we can diagnose and fix the problem back at the shop. So when it comes to the other type, the electronically assisted thermostat or map controlled thermostat, we still have a wax pellet, similar to this one, maybe a little bit smaller and more likely opening at a higher temperature. Instead though, we also have an electronic heating element inside to control when that wax pellet opens and closes. The ECM controls that heating element and will open the thermostat when it deems it needs to. So it can stay closed for longer to get the engine hot faster and to a higher temperature to meet emissions, but it can also open it preemptively even if the coolant temperature isn't that high based on load and other factors. So we know the engine's going to get hot fast, we want to open the thermostat earlier. We have a sensor in the block, same as we do for this one, and that'll tell the ECM, along with other factors such as load and engine speed and temperature outside, what it needs to do with the heating element, whether it needs to open and close that thermostat preemptively or leave it closed for longer to get the engine hot. It gives us a lot more control over the thermostat, and we can also check any issues with a scan tool as well. So are electronically controlled thermostats better? Well, it depends what you want. For me in life, I don't need a lot of performance and emissions aren't really a big deal because my cars are all very old. These are perfectly fine. They've worked for a million years. They're cheap, easy to change, and if you have a problem, you can just pull them out and run no thermostat at all. Of course, if you're worried about performance, and of course, cars that are being manufactured nowadays must meet higher emission standards, electronic thermostats are the way to go. They obviously give us a lot more control over the cooling conditions inside the engine. In this case here, we can bypass a lot more fluid than we would with a regulator like this. Typically, an engine equivalent to the engine that comes out of this particular truck would have 4 very large regulators. With this case here, it's all replaced by one thermostat, but of course they are very costly. This system here, if you were to buy an electronic thermostat for this particular truck, it is $16,000. And the same goes with the electronically assisted thermostats in cars nowadays. Replacing one of these might be 15 bucks. Replacing an electronically assisted thermostat is a lot more money. The idea is they're supposed to last the life of the vehicle, and they're proving to do so, but they can go wrong. And when they do go wrong, they will cost a bit more money than a standard thermostat. So it all comes down to application. For me, these are perfectly fine, but obviously the industry is going towards electronically assisted and electronically controlled thermostats for good reason, and they're definitely here to stay. Thank you very much for watching.